Hey y'all, so back with another video. So we've been recently working with solving systems of equations. We've done so by graphing, we've done so in the calculator, and now we're gonna do so algebraically, because sometimes in the EOG they won't give you a graph, or they'll give you graph paper but it won't have the coordinates. You'd have to create that. But if you know how to solve it algebraically, or you know how to do it on your calculator, but sometimes it's calculator inactive, you'll be able to do it. All right, so we want to set you up for success there. So I need you to watch what I'm doing. So we're going to start with the notes at the top. So steps to solving a system of equations. All right, so two equations. How do we figure out what the x coordinate and y coordinate are at their point of intersection? So you have to set the first equation equal. Let me try to get equal to the second equation. It looks like a V. Equal to the second equation, all right? Then you have to solve for x. And you're gonna do so. We've learned how to solve equations, so this part we should know how to do, all right? After you solve for x, you're going to plug in x into one of the equations, all right? Does it matter which one? No. I'm gonna write this way, okay? If my hand is in the way, y'all be all right. One equation, all right? And then you're gonna solve for y. So you solve for x and you solve for y. So now you have an xy point, and you'll see how that works out. So here's a little piece, some pieces of information. So far, we've been seeing one solution, no solution, infinitely many solutions, right? But here is what it means. So for a one solution equation, it has different slopes, okay? So they're gonna intersect at one point. For no solutions, they have the same slopes but different y-intercepts. So the slopes are the same. So if you come to two equations, you see the slope is the same but the y-intercepts are different, then you know it's going to be no solution because they are parallel lines. All right, now if you see same slope, same y-intercept, essentially it's the same equation. They intersect everywhere. It's the same line. It's stacked on top of each other, so there's no solution. So let's look at the following. So y equals negative 3x plus 4, y equals 4x minus 10. So this is going to be one that has one solution, and you'll see why. So y equals negative 3x plus 4, y equals 4x minus 10. My first step is to set the first equation equal to the second equation. So what I mean by that is you're going to take this part of the equation and this part of the equation, and you're going to set those two equal to each other. So negative 3x plus 4 equals 4x minus 10. All right, so I set this equal to that, but not the y. So you see I didn't include the y. So however you solve equations, you are going to do so by solving for x. My students like to use the box method, so I'm going to use the box method. So we have variables on one side, constants on the other. I'm going to create my box. All right, divide that in half. How many variables do I have? I have 1, 2 variables. Divide that in half. My first, and how many constants do I have? I have 1, 2 constants. So I divide that into 2. So variables have to be on the left side. So this negative 3x is already on the left, so I'm going to keep the sign. I'm going to write negative 3x in. So I got rid of that variable. All right, 4x is on the right. I have to move it to the left, so I switch the sign. It's positive, it becomes negative. So negative 4x. Now my constants. My constants have to be on the right, so it's the opposite of variables. Constants have to be on the right. This 4 is on the left side of the equal sign, so it's going to switch signs when I move it over. So it's going to be negative 4. And this negative 10 is already on the right side, so I'm not going to switch it. Negative 10. All right? If you like to solve it by moving your constants and then moving your variables, do it however you know how to solve equations. Just make sure you get accurate answers. So negative 3, now I'm going to add negative 3x plus negative 4x is negative 7x. And negative 4 plus negative 10 is negative 14. At this point, I'm going to divide. So divide by 2, divide by 2. Why am I dividing by 2? So I'm dividing by whatever's in front of the x. I'm going to divide by negative 7. That is my fault, y'all. Divide by negative 7 on both sides. So this cancels, right? You get rid of it. And then you're left with x equals negative 14 divided by negative 7 is 2. All right? So remember, we're looking for a coordinate. So this coordinate, we know the x value is going to be 2. Now we got to figure out what is y. So we We set the first equation equal to the second equation. We solved for x. Now we have to plug in x into one of the equations. All right? So we know x is 2, right? We solved for that. So I'm going to take this 2 and I'm going to plug it into either this one or this one. Does not matter which one. All right? So say I use the first one. So that equation is negative 3x plus 4, right? Or y equals negative 3x plus 4. So now I'm plugging in 2 into x. So y equals negative 3. And negative 3x means negative 3 times x. So I'm going to put my x in parentheses so that I remember to multiply. 2. Realize the 2 came from solving for x down here, right? And then plus 4. That's the rest of the equation. So y equals negative 3 times 2 is negative 6 plus 4. Negative 6 plus 4 is negative 2. So y equals negative 2. So my y value, so my x value I solved for was 2. My y value was negative 2. So that's where they intersect. That's their point of intersection. All right? So remember, set the equations equal to each other, solve for x, plug in, solve for y. All right? So let's look at number 2. Number 2 and number 3 I could solve for, but if I remember my rules, I don't have to solve for anything. So y equals 3x minus 5 and y equals 3x minus 5. The slopes are the same. The y-intercepts are the same. So m is 3, b is negative 5. And if it has the same slope and the same y-intercept, it's infinite solutions. So I can write infinite solutions as my answer to number 2. All right, so let's look at number 3. Okay, so my slopes are the same, but my y-intercept is different. That means these lines are parallel. Same slope, different y-intercept. They're parallel lines. There's no solution to that. So if you remember your rules, it becomes a little bit easier. All right, so now let's try one with a fraction. If I see something like this, first thing I want to do is I'm going to set the first equation equal to the second equation. Set this equal to this. So 5x minus 3 equals 1/7 x minus 3. Okay, so the slopes are different, so I know it's going to be one solution. If slopes are different, then I know it's going to be one solution. So I need to solve. So I have this 1/7, and we hate working with fractions. Here's what you can do. You can multiply the denominator. You can multiply every single number by the denominator of the fraction. So I'm going to multiply this 5x by 7. I'm putting it in parentheses to tell me to multiply, right? I can multiply this negative 3, this minus 3, times 7. Multiply this by 7, and multiply this by 7. So 7 times 5x is 35x. Minus 7 times 3, that's 21. Equals, and 7 times 1/7, here's a trick. The denominator gets canceled, and you're left with your numerator. So if you're, so say it was 3/7, and you multiply by 7, it'll be 3. But it's 1/7, so it's going to be 1x minus 7 times 3 is 21. All right, this is for fractions. You won't see many of them, I hope, but it's good to know how to do it. So now we solve for x. So variable on left side, constants on the right. So how many variables do I have? 1, 2. Divide that in 2. How many constants do I have? 1, 2. Divide that in half. Cool. So I get 35x minus 21 equals 1x minus 21. So first variable I see is 35x. It's on the left side of the equal sign, so I keep the sign. Done with that variable. Next variable I see is 1x. It's on the right side of the equal sign. I want to move it to the left, and when I do that, it becomes negative, so it'll be negative 1x. Done with that variable. Now I have my constants. My first constant that I see is negative 21, right? We want constants on the right side of the equal sign. So to move it, it'll become positive 21. But this negative 21 is already on the right side, so it's going to stay negative. Remember, minus signs double as a negative. Minus signs double as a negative. So now I solve. 35x plus negative 1x is 34x. 21 plus negative 21 is 0. If you have a positive number and a negative of the same number and you're adding it, it's always going to be 0. So like negative 5 plus 5 is 0. Negative 4 plus 4 is 0. A negative and a positive number are the same. If you're adding it, it's 0. So We're going to divide by 34 at this point. That cancels, x equals 0. So I know my x is 0. So the solution to this will have 0 as the x coordinate. Now we got to figure out the y. I have to plug in my x into one of these equations. I always choose the first equation just because it's easy and I don't want to deal with this fraction. So y equals 5x minus 3, right? Now we got to plug in for x. So 5x means 5 times x. Y equals 5 times, we found out x was 0 down here. So I'm going to put 0 in parentheses and then I'm going to subtract 3. Y equals 0 minus 3. 0 minus 3 is just negative 3. So my y is negative 3. That's the point at which they will cross. They will intersect each other. All right? So go off on your own. You're a free bird.